Well, it's finally happening where they're starting to frame the house. We're going to take a look at this here. And I've been away for the last few days visiting my mother out of town, and I was hoping they were going to start framing this. They haven't gotten very far yet, have they? I'm going to say that this is the equivalent of maybe 2 guys framing all day long. And that's about it. If they had 4 guys here, they would have framed up more walls. But not so. But they've got a little bit. So I know in the next few days they're going to be doing some more. Okay, this is what your framing is going to look like. All right. And I see these walls. These walls look like they're about 10 feet tall. I don't have my tape measure on me, but this looks like about 10 feet tall. And let's just take a meander here. Now see this here? This is what they call a trough. And they build that when they have an let's see if I can find a place here where they have 2 walls together. See, here's the trough right here. See, that's what I call the trough. And then they would put that in there because why is that there? Let's just take a look at that for a second real quick. See, that way this wall here that comes across can tie into that, and then they have 1 2x4 here and 1 2x4 on the other side. You got to have that for sheetrock backing. That's the sheetrock backing. If they didn't do that, then you would only have the sheetrock backing from here on this wall, and then you wouldn't have anything at the corner to nail your sheetrock to. You've got to have sheetrock backing on both sides. See, so for every wall intersection, like where this wall is tied in to there, you've got sheetrock backing on that side, sheetrock backing on this side, and so they would just nail 3 2x4s together, boom, boom, boom. And then they would fit that up there in one go as they're framing the wall down on the ground. Okay, and see, they've already started bracing some of the walls temporarily. Once they frame up all of the walls, they'll go back and straight line all of this, and straight lining meaning put a string on the outside of the wall and maybe 3/4 of an inch over, and then they would hold a 1x4 up there, 1x4 up there, 1x4 up there, all the way along there to make sure that the wall is nicely straight all the way through there. And see, they've done a really good job now of this, how they've lined it out and they've compacted it, and they've made that look really nice, getting ready to pour concrete in there. I can see where the chalk line is 4 inches above this. You can't really see it, but I can see it, and they've done a really good job with that. Okay, and they're just going to leave that until they get ready to frame, or get ready to form that. And see, on some of this, I find it interesting. The exterior walls are 2x6 walls. That's a 2x6 wall. Okay, the interior walls, some of them are 2x4 walls. See, this is a 2x4 wall, and that's a 2x4 wall. But the next wall is a 2x6 wall. See there? And then they also have a 2x6 wall over here. Now, why would some of the interior walls be 2x6 walls, and some of them be 2x4 walls? See, here's another 2x6 wall there, and then there's a 2x4 wall there, 2x4 wall there, 2x4 wall there, and then that's tied in with the 2x6 wall. I'm not quite sure. Probably on the plans. They'd have to look on the plans and see which walls were 2x6, which walls were 2x4. Whenever we built walls, we built them all the same. Well, nothing's built the same anymore from 30 years ago, and so you would have to look on the walls, on the plans, and see. Now, see, these walls are 10 foot tall, and see how they built the header across here. They built the header across here, and they've got 2 trimmers. I call these 2x6s trimmers because they just go up to the bottom of the 6x what is that, a 6x10 maybe, it looks like. And then this is a king stud, which runs all the way up there, and then you nail that into that, and then you got two trimmers here that holds up the weight. And you got two trimmers on that side. Okay. And because that's a 2x6 wall, that's a 6 by 6 inches wide by 10 inches tall for the header. Whenever we did our framing, obviously years ago, 8-foot walls with 6'8" doors. All these doors are 8 foot tall, I can see. We would just use 4x12s above the door openings, the window openings and all that, because then the two top plates were right above that. Well, here I see it. I see something interesting happening here. Some of these doorways don't have any headers across there. See this? This is a 2x4 wall, and the header is just two flat 2x4s with some cripple 2x4s above there. See there? Right there, right there. There's no header, is there? There's no header there. There's no header there. There happens to be a header on this one. There happens to not be a header on that one, meaning a big 4x material, or this is a 6x10, it looks like. And funny thing is, they don't have the trimmers in there yet. See underneath? For some reason they don't, but down here, see, the K is for king stud and two trimmers. Two trimmers here and a king stud. Well, for some reason they didn't put the trimmers there. And on this one, they didn't have to put any trimmers because there's no header like a 6x10 header material going across. And so that's because that is not a bearing wall. This wall going across. And they've determined, see here, here's another header here, and they just haven't, I don't think they've put the trimmers yet, and they are going to be calling this a bearing wall. Where this header is here, that's going to be a bearing wall. What is a bearing wall anyways you're talking about? See here, here's another header going across here, and on this particular one they only have one trimmer up there. You know, what's the difference? And that is going to be considered a bearing particular wall. So when they install all their trusses above this, maybe certain trusses can only span certain distances. Maybe it can't span all the way, and so some of the trusses coming across, because how they built this house. Remember, it comes across, and then it skews off that way. So when their trusses come across here, maybe these trusses have to end here, and maybe there's some other trusses that go from here that direction, and some other ones that come across. And so on some of these walls, they're calling them bearing walls and non-bearing walls. The non-bearing walls obviously is this one, because there's no header across there. And the guys who are framing this and forming it, building it, they've got to look on the plans and see which walls are bearing walls, which walls are non-bearing walls, apparently. Okay, because they don't have any headers going across there. If that was a bearing wall, you could not build a header area like that without a beam up there like this. Do you see what I mean? I might be getting too technical on you. I'm not sure, but hopefully you understand that. And you've got to look on the plans and make the determination what's going on. Okay, so they've only done a little bit of the walls so far. Obviously, tomorrow, if I come here tomorrow after work, chances are, if they show up tomorrow, which I'm hoping they do, they'll have probably another third of this house framed. Okay, or maybe more. Could they do all these walls tomorrow? Yeah, they could do the rest of the exterior perimeter walls, all the interior walls, and all this over here if they had 4 or 5 guys here tomorrow. If they only have 2 guys, then obviously they're only going to get about this far again, which means maybe from this point on over this way, and maybe that's all they do tomorrow. Who knows? So we'll see what their progress is tomorrow, and I'll talk a little bit more about what's going on. Remember if you were with me before, when they lay these walls out, they only laid out a bottom plate and a top plate, okay? And when they lay it out on the wall, on the floor, and they put it all together, then before they stand it up, they'll actually install a top plate on top of there. See how the top wall now has 2 plates up there. See, you see up there, there's 2 plates up there, but when they first do it, they've got only the top plate and the bottom plate, and then they have to make a determination of, do they have any inner joining walls? So then the top plate will only go, the top plate will only go from here to there, and then this wall that comes along here, see where the wall, we've got 2 lines, we know there's going to be a wall right there, and they've got another pig's trough. I call that a pig's trough. See how they got the 3 pieces, kind of like how they nailed that together before they put that in the wall before they stand it up, so that they have sheetrock backing on this side and on that side of the wall. Okay, so when they put that wall up, they'll go up to there and see where they cut that top plate short on both sides. Then this wall that comes across, that top plate, all the way top plate, will go all the way across, and that's what ties in the top together. Do you see? You see how this wall that goes that way, the top plate, they should have ran the top plate further, but you can see it up there, and that ties that in. And see how they cut this one back, because that wall, this wall goes across, that top plate will connect from there all the way through, and that'll tie this wall and that wall together. You see? And so when they build the walls on the floor, they've got to figure out, okay, where's those plates? Which top plate do we need to extend? You know, whatever thickness the wall is, or do we cut it back? And then when they actually build the wall, like when they build this wall here, okay, the very top plate, they'll nail that and extend it 5.5 inch, 5.25 inches longer, so that when they flop it up there, they'll flop it up from this way, and the top plate will actually extend over, and then they just nail it down on top of there. See what I mean? And then when they build everything, then they rack it into place. They plumb it, and they'll rack this wall over this way or that way before they nail this diagonal brace on there. They've nailed that. They just tacked it with a couple nails down there, and then they have 1 nail there and a couple nails up there. Well, they did that before. They first plumb the wall up all together, and then whichever way it needs to go, they'll push it over that way or this way, and then they put a brace on there temporarily. They'll put it on there. Now they might have leveled it, they might have plumbed it up, or they might have just tacked it just to keep it from falling down or something, and maybe they've done a few diagonals, and this one here, maybe that wall is not perfectly plumb yet or something like that. But after they get all the walls built and all of them put together, they don't necessarily have to have each individual one plumb, as long as they know that it's all nailed together. Then when they get all done, then they start racking each wall section, and when they do this wall, it'll hold. It'll be plumb there, and then whatever other wall they have hooked together on it, that'll be plumb. The next one will be plumb. They might have 4 walls here that they plumb all at the same time after they rack it back and forth, and then they check it with their level. If they check it with their level right here, they know this wall is going to be plumb. This wall over here is going to be plumb because it's nailed onto there. This wall is automatically going to be plumb. This wall is going to be plumb, and so forth and so on. Do you see what I'm saying? And so they'll do that at the end. So these braces here, they could, they could check them. I'm sure they have not racked every single one of these yet and jet lined them, straight lined them, and all that. You kind of do that after it's all said and done, because you want all your exterior walls, these interior walls that hold the exterior wall that's attached to the walls. You want all those plumb, but you want this last wall nice and straight. So when you put your last roof truss up there, it lines up nice and straight. And then when you get your trusses on there, before you nail them down, all these interior walls are going to be nice and plumb, and your exterior walls are going to be nice and straight, because all of your trusses are already pre-built and they're already pre-measured. And when you put them up, your truss at this point needs to be nice and straight in lieu or in line with this other perimeter wall. It needs to be nice and straight. Do you see what I'm saying? So they'll check all that when they get all done framing all of the walls. Okay, so it's really quite fascinating that the builder has to build it exactly right, and that's why they got to follow the plans right to the T, so that they know that when the trusses come out, they're not gonna. You can't start modifying new trusses, because those are all built and designed to span the actual distance that is shown on the plan. So when you build your walls, the walls have to be exact, because the trusses are built exactly as per the plans. You're not going to come out here, oh, this truss needs to be modified by an inch. No, you can't do that. You've got to line everything up. That's why all your outside walls have to be all nice and straight, no bows, no ziggly wobbly lines on it for a whole long line. Let's say on that last wall. See, this is all cut up so much, you don't have a whole lot of lines to deal with. This one, that one, that one, that one. But yet when you pull your jet line string or straight line with some twine or something, it's got to go all the way across, so that you know. And then that one's got to go all the way across. And then you might have to start measuring with big long tapes to say, okay, the trusses are supposed to be 28 feet 2 inches long. And then you pull a string from there to there. You're double checking certain things. You may have to tweak your walls in case the flooring is slightly off, to your new walls that you're building. And you might have to tweak your perimeter wall. And maybe your perimeter wall is not, maybe it's supposed to be flush right here, but maybe it's supposed to be flush over there. But then when you measure flush over there, maybe it's slightly off. Maybe it's 28 feet 2 inches over here and 28 feet 2 1/4 inches over here. Then you've got to decide, okay, what do we do? Do we move this wall slightly over 1/8 of an inch? Do we take that one over this way 1/8 of an inch, so that when it's all built and done, we've got 28 feet 2 inches on this end as opposed to that end, and vice versa. So you've got some measuring to do. And that's why when you form out everything to build the footings and the stem walls, you've got to make them exact as per the plans, because all your trusses have to fit. Years ago, they didn't have trusses. They built everything by hand. Okay, each truss is individual, or each rafter was individual, each ceiling joist was individual, and they built everything by hand. And then you can pick and choose. If something's off slightly, hey, no biggie. We're building it by hand, and everything's done by hand. But when you get the trusses out here, those are already pre-formed, pre-manufactured. The stress loads have already been figured out. You don't just order a truss online or something. You actually have to get somebody to engineer your whole house with your trusses, and then the truss company has to look at that, and then they have to say, okay, what's going up above it, how far is the span, and that'll determine how they build the trusses, how they design their trusses. Then they have a whole booklet, it's probably about this thick, that goes with the plans in plan check. And then the engineers at the county building department, they have to look at it and make sure the design is properly, so that the load is structurally sound to hold up your ceiling, your sheetrock ceiling, your roofing, whatever you're roofing. If it's roof tiles as opposed to asphalt shingles, maybe it has to be designed slightly differently to allow for the heaviness of your tiles. If you have a second floor on here, obviously you've got to have a floor load as well as a roof load, and then you've got to have your roof, your floor joist, depending on your spans. That'll determine what height your floor joists are to hold up your flooring, and then your walls on top of the flooring, and then your roof on top of that. You know, it all has to be coincided. But I'm pretty sure, if I'm not mistaken, this is all going to be a single-story house. So all the trusses are going to span from here all the way across there. So the attic area is going to be pretty tall, is my guess, because of how wide this is. See how wide it is over here? My word, from here all the way over. So we know somewhere that the trusses from there somehow are probably going to stop on some of these interior walls, and that's why some of them's got headers, some of them don't have headers. In the old days, we used to build all the walls, all the perimeter walls and interior walls were like 8 foot tall, and all the doors were 6'8" tall. And so we just put a 4x12 automatically on every single door opening, whether or not it was a bearing wall or not. And that's just how we did it. Nowadays they don't do that. Most walls nowadays are 10 foot tall, and most doors are 8 foot tall as opposed to 6'8" tall. Okay, and that's just so that when you get in a house like this, you like to have the ceilings a little bit higher, and because you've got higher ceilings, you wouldn't have 10-foot ceilings on a house with 6'8" doors as opposed to 8-foot doors. If you wanted to be chintzy and say, I'm just going to put 6'8" doors in here, the doors would look small, would look short, because the ceiling is so high above the door openings. That's why on most 10-foot tall ceilings or 9.5-foot tall ceilings, they go with 8-foot high doors. Okay, so these are framed for that. In fact, this one here might be a double door, or something. I should have brought my tape measure out. Maybe one time I'll bring a tape measure out, and we can do some measuring. But most of your interior doors are different sizes. 2'8", 2'8" wide for your bedrooms, and lots of your bathrooms are 2'6". But you know, I did talk to you about handicap accessibility. If you're building a whole house for yourself, and depending on how old you are, you might want to figure on 3-foot wide doors to make it handicap accessible, because handicap accessible is 2'8", 2'10" inches, I think, 34 inches, I think, opening, and you couldn't do a 2'8" wide door because of your door stop, and when your door opens, you don't have 2'8" 2'10" inches open space if you put a 2'10" inch door in. So you would put a 3-foot wide door in. You see what I'm saying? But anyways, I'm kind of rambling because the sun has gone down. Look at that beautiful aftermath glow of the sunset that went down over there. I'm trying to get this in and give you enough information as I can. Obviously, tomorrow I'll come out here and there'll be more of this framed, hopefully, and I'll talk about more. We'll look at sheetrock backing areas in certain aspects, and framing certain things and why they did this as opposed to that, and maybe some different things. So stick around next time, because it's getting dark, and I think I'm gonna have to go for now. So that's all I got for this time, but I'll be back with more videos. And as you can see, the video camera is getting a little bit darker because it's darker now. And see, I can't really show you much more at this point. We'll just have to come back tomorrow and I'll talk more about how to build a house. Well, I guess that's all I have for this time, but I'll be back with more videos, and I'm enjoying bringing all these videos to you, and I hope you're liking them. If you do, give me a thumbs up, give me a comment, send me any questions that you might have on how to build a house. You can go to my playlist. You can always find all of my other videos on how to build a house in my playlists. And what's my playlist? Where can you find them? Go to my main YouTube channel page, click on playlists, and scroll down to how to build a house.